So you record some evidence, and based upon that evidence, you identify the conditional probabilities. So this is what you call as the conditional probabilities, or the probabilities of uh, some event given some evidence. Okay, and that's what we'll try to identify from the data. Okay, so we'll study the complete pipeline, that if you are given some data, that how can you find out the probabilities of occurrence of an event given some evidence, and as the evidence changes, what happens. Okay, um, so let's try to understand that how this could happen. Okay, so the first way that you can have in inferencing based upon some probabilities is through enumerations, and we have discussed this last time a little bit, and this would be just a sort of a revision that we have done last time. So suppose you have got some variables which are called the evidence variables. Okay, so you have got some evidence variables with you. You have got some query variables. Query variables are those for which you want to find out the answers. And there might be some hidden variables, those variables that are not known to you. But anyway, we'll not be considering these variables separately, but primarily we'll be focusing on these two variables. Okay. And here is what we want to find out. We want to find out the probability of occurrence of our query variable Q given some sequence of evidences. Now, this is important here, sequence of evidence. So you have sequence of evidence, that means that you have got evidence 1, then you have got evidence 2, and you might have got like number of evidences equal to k. So you have k evidences that are known to you. And based upon those k evidences, you want to find out the probability of occurrence of a particular uh, event, and let's call or variables, that is that is what you call as q. Okay, so there is one thing that and you can see that what is happening here is that you here all these evidences may occur together. Okay, say for example, in the last example we said that okay, the probability of buses arriving on time given the time of arrival is, let's say, 5 in the morning, and it's raining and it's weekend, stuff like that. So 5 a.m. raining and arrival and weekend, these are all different evidences that are present, or number of accidents or any accident that is reported. These are all events. Okay, so let's say we have got the probability of these events. These are the joint probabilities of these events. So you need to find out, in order to find out the conditional probabilities, you need to find out the joint probabilities of all these events. Okay, so all these events, so they may occur together, so therefore इनकी joint probability आपने निकालनी है, and at times finding out the joint probabilities is difficult. Okay, so you may not be able to find out the joint probabilities whether all these events take place at the same time or not, or all these evidences can be collected jointly or not. Okay, with an input. So if you are unable to find out these joint probabilities in this particular form, then what you can do is that you can use this a condition of independence. The condition of independence means that you will assume that all these evidences could occur independently, and that is in some cases and in other cases, in some cases it might be true, and in other cases it may not be true. For example, you can say that, okay, it could rain at 5 a.m. in the morning with some accidents reported. I mean, they can coexist. There is no issue with that. Okay, but still, we'll assume that they are independent of each other. Say, for example, we'll assume that accidents have nothing to do with rain, or accidents have nothing to do with the time. Um, okay, or accidents may not have anything to do with the foggy weather, though in reality this is not true. This might be a possibility. Okay, and this is a possibility because accidents would definitely have some relation with the weather. Okay. But we assume that they are independent, and that is what the independence assumption is. And if you use that independence assumption, then you need not to find out these probabilities, joint probabilities. You can find out their individual probabilities and simply multiply them together. So you can approximate these joint probabilities by through this independence assumption, assuming that these events are independent. You can find out their probabilities separately and simply take the product of these. Okay, so in that case आपको ये requirement नहीं होगी कि आपने इन evidences की probabilities जो हैं वो joint probabilities निकालनी है कि whether they can happen say together or not. ठीक है, so you can assume independence, and that means कि आप separately उनकी probabilities निकाल सकते हैं और उनका आप product ले सकते हैं, and this could go up to ek. Okay, so finding out the probabilities independently is easier, right? So finding out probabilities independently is easier rather than having joint probabilities. Okay, so that's because of this independence assumption. So you are assuming that the variables that you are talking about, or the evidences that you are talking about, they are independently occurring. Okay, and if they're independently occurring, that means that you can find out their individual probabilities separately without looking at any other evidence, and then you can take their product. This is what independence is, and this concept of independence will be used in future for inferencing. Okay, and the same actually stands for conditional probability. So here, if you can see here, so this is a conditional probability, the probability that of a query variable given a sequence of evidences. Okay, so this is, let's say, Q, okay, given E1. So let me just take only two evidences in view. So E1 and E2, and this is a conditional probability. And if I use this independence assumption, I'm saying that E1 and E2 are independent of each other. Therefore, E1 and E2 can occur independently. As a result, in order to find out this probability, I don't have to find out the joint probability of E1 and E2. I can simply say that I can find out the probability of Q given E1 separately, which is definitely easier to find out. And then I can also find out the probability of Q given E2. So this conditional joint probability of evidences can be written in this form by taking assumption of independence. So I hope this is clear. So we have to, so if there are too many variables that are associated, and it becomes almost next to impossible to find out their joint probabilities, because you may not have the data arranged in that particular form. Therefore, an easy way out could be that you can assume that these evidences are independent of each other, and therefore you can actually treat them separately and find out their conditional probabilities or other probabilities in by treating them independently of each other. Okay, so that's something that you need to keep in mind. Okay, so let's say maybe here we may not be using this condition of independence. We might be using this condition of independence later on. Okay, so here if the inferencing has to be done through enumeration, then let's say you need to find out this, which is the probability of occurrence of a particular event. Let's say Q given a sequence of events. Then the steps, I'll just go through the steps. Is that firstly you have this table of probabilities, and from there you select the entries that are consistent with the evidence. For example, from the table you can find out the value of the probability where Q was, say, Q occurred given some evidence E1 up till EK. You separate out all those columns or sorry, rows from your data. Okay. You do some sort of marginalization that we discussed last time. क्यूरी और एविडेंस की बेस के ऊपर उनकी जॉइंट प्रोबेबिलिटीज आप उसकी जॉइंट प्रोबेबिलिटीज आप निकालते हैं, ठीक है, बेस्ड अपॉन सम एविडेंस. सो इफ ऑल द एविडेंसेस आर देयर देन ऑब्वियसली द कंप्लीट only those entries जिसमें तमाम एविडेंसेस रिकॉर्ड हुई हुई हैं that would be taken. If let's say E1 के लिए सिर्फ आप probability of Q given E1 निकालना चाहते हैं तो you will select only those rows जिसमें Q और E1 coexist. तो यहाँ से in a way joint probabilities की entries जो हैं वो आप अपने टेबल में से probability टेबल में से आप निकालें. And then primarily this is what would happen. So once you have separated out, you have got the joint probabilities for your calculations. So joint probabilities उसमें से निकाल लें for some evidences, and then you do the normalization step. And the normalization step was discussed last time, that how this normalization step can be taken into consideration. So you actually do that normalization and find out the answer. This is the conditional probability that we discussed last time. So in order to understand that how this normalization is done, you have to refer to the last lecture, the last lecture, in order to understand that. Okay, so suppose this is the table that is given to you. From here you want to find out the probability of W, that is the weather. It could be sunny or rainy outside. Then you can find out the probability of the weather. That means that you actually simply S or T को इस table से आप eliminate कर दें, or you only find out the probability of W given that. And we have discussed that last time कि कैसे आप करते हैं. We have already done that. Then conditional probabilities, the probability of W given winter. So here you will only be referring in enumeration, you will only be considering these rows, because these rows are actually satisfying your condition. And because in this probability T is not considered, so you will actually try to marginalize T out of this. Okay? So you will actually eliminate this and then find out this conditional probability, as we discussed last time, using the joint probability and the marginalization of through marginalization of T also. And then if you have got some other evidence, for example, you want to find out the probability of W given winter and hot, then in that case, you will basically be considering those tables, those rows here in which the condition is satisfied, and that would be winter and hot occur together. So winter and hot basically occur together here, and winter and hot occur together here. So these two rows are taken into consideration, and then the same process that we have discussed last time is applied. And we have discussed this in detail कि कैसे इसको apply करना है. So you apply the normalization trick, और उस normalization trick की base के ऊपर you can enumerate and find out the answer there. Well, this process is actually quite complicated, and therefore, for larger data sets, it may take a long time. Therefore, in terms of the time complexity and space complexity, this process takes a lot of time, because in order to carry out this process, you have to have this table, okay, and this table that you have got here, okay. So this table here is the table of joint probabilities. So S, T and W की various values और उन तमाम की joint probability निकालना. And as I told you, this is at times really difficult to find out. Therefore, as we discussed earlier, an easier solution would be to actually assume independence, and that is something that we'll be discussing later. Okay. So how can you have a conditional distribution? So joint probabilities को निकालने के लिए, so if you want to find out the joint probabilities, and you can't really directly measure them. So if you are unable to measure them directly, then you can always find these joint probabilities through the product rule, and this is what the product rule is, right? The product rule is that you find out the conditional probability of x given y times the probability of y, and that would give you the joint probability of x and y. ठीक है? Or अगर आपके पास, let's say, you can use this product rule in different ways. For example, if you have got the joint probabilities with you, then you can find out the conditional probability from here, as in the last slide, that you are given the joint probabilities and you can find out the conditional probabilities. And you can do it the other way around also. If you are given, let's say, the probability of y and the probability of x given y, you can simply take the product of these two and find out the joint probabilities. And this is also something that we discussed last time. So for example, here you have got the probability of w and the probability of d given w. From here you can find out the joint probability of d and w together by doing, okay. So what would be the answer in the first cell here? Say, for example, what would be the answer here? G, anyone? Okay, the answer here will be 0.8. So this would be probability of wet given sunny times the probability of W. So this would be, will that be 0.8? Okay, so this would be 0.08. Okay, so this would be this probability times this probability. Okay, using the product rule. So this is primarily this, and this value that you have got here is this. You simply take the product of these two, and this entry comes out to be. So this is how the joint distribution can actually be calculated. So you're right, Maz, and you're right, Abdullah, in this. Okay, so this is how you can do it. You can do it the other way around also. For example, if you've got the joint distributions, and if somehow you are able to find out the joint distribution, you are going to find out these conditional distributions. You can do that by dividing the joint distribution with this the marginalized probabilities, which is P of W, and you can also like call it the priors. The marginalized distributions are also called priors, right? Okay, so by the way, there is one other thing that you can also do here, and that is कि एक तो मैंने आपको ये बताया कि this is how you can actually find out the joint probability. Is there another way to find out the joint probability? So let's say कि आपके पास ये P of x, y है, And what has been written here is that you get the conditional probability of x given y times y. You can find out this joint probability the other way around also. So you can also, let's say, write down that the probability of y given x, right, times, and now it would be the probability of x being multiplied in this particular case. Okay, so this is also a way to find out the joint probabilities, and then that would mean that this side here is equal to this. Okay, so you can also like equate it to the probability of x given y times the probability of y, right? So any of these two things can be done. So either you can do this or you can do this to find out the joint probabilities. Both of them are equal. Now this is quite important because this would be used for inferencing later on. Okay. This would be used for inferencing, especially when, let's say, if we qualify y by something. So let's say if we say that y represents a disease and x represents a symptom, then the probability of a disease given a symptom times the probability of symptoms is same as the probability of the symptoms given disease times the probability of disease. Okay, so this result is quite important, and that will be used later in our discussion. So you have to keep this in mind before we actually move on. Okay, so this is the chain rule. The chain rule I've already given you an example for that, and that is primarily under uh, the assumption of let's say incremental product of conditional probabilities can also be used. So this is a sort of a background to the inferencing process that you need to know. Say, for example, if the joint probability of certain variables has to be found, then you can have this chain rule applied, and this chain rule would say that, okay, you have the prior or the marginalized probability of x times the conditional probability of x1 given x2 given x1 times the probability of x3 given the remaining three evidences. So this is again the chain rule that could give an approximation of the joint distributions. Okay, and in general, this is how this is actually representing. So you incrementally increase or you incrementally take the product of the variables, and this is how the joint distribution can also be determined. Okay. So this can also be applied in order to find out the joint probabilities in this case, and this is what you call as the chain rule. Okay. So the product rule can be used, and if you have more than one evidences, then you can use the chain rule to find out the probabilities in exactly the same phase. So this applies to a sort of an independent. This applies to when you have got more than one evidences. Though the independence assumption would also be applied in this particular case. लेकिन अगर conditional probabilities के साथ अगर आपने निकालना है तो then this is something that you can always do. ठीक है. So incrementally increase or change in these probabilities here. And as I told you that there could be different ways of interpreting this. This could depend in what sequence the evidences have appeared. You can take into consideration that sequence, or otherwise you can do it without taking any sequence into consideration and use any incremental form in order to find out the probabilities. Okay, so with this background, an important result that we can infer from these joint distributions over variables, and especially over two variables, and that could be done through the Bayes rule. As I've just explained you this in the last slide, um, that you can have the joint distribution either through this form or through this form, and both of these are same. Okay, they will give you the joint distribution. So both of them are same. Okay. Now from here, if I want to find out this probability, which is a conditional, which is P, the probability of X given Y, I can take this factor and divide it on this side and find out this probability, which is a P of X given Y. Or if I want to find out this probability, which is the probability of Y given X, I can take this marginalized probability of X and divide it on this side, and that would give me this conditional probability, or in this probability that we have got here. Okay, so I can rearrange this, and this is what I've got here, right? Now this rule that you have got here is what you call as the Bayes rule. So this is how you can actually find out, change the condition and find out the probability for the change, for changing the condition. So here, let's say एक probability of x given y मैंने निकालनी है, so I can use this. A probability of y given x निकालना है, तो I can actually find out from this equation, from this equality. I can actually do that. There is no problem in doing that. And this is, by the way, the base of probabilistic inference in machine learning. Okay. And one of the most important equations that are used in AI or in making decisions. So here is an example that how inferencing can be done using the Bayes rule. We'll have a complete pipeline in a while. So let's say if I want to find out the probability of some cause given some effect, then I can find out the probability of effect given cause times the probability of cause divided by the probability of effect. So let's say I've got a condition in which I want to find out whether a person is suffering from meningitis or not, given that the person is having a stiff neck. And the probabilities that are given here are the probability, the prior probability of meningitis is given, the probability of stiff neck given meningitis, and the probability of stiff neck given no meningitis. So these are the probabilities that are given, and these probabilities are primarily found from the data. Okay, and we'll see in a while कि data से आपने ये कैसे निकालना है. And then here, what we want to find out that whether this person is suffering from meningitis or not, given stiff neck. So this is the probability that we want to find out. The probability that the person is suffering from meningitis given stiff neck, plus means that the person is suffering, plus S means that the person has this stiff neck say symptom. So from the Bayes rule that we have discussed earlier, we can find out from the given data, we can put on these values by putting these values of the probability of S given M times the probability of M divided by the probability of S. And if you remember, you can find out this probability through doing some sort of marginalization that we have actually discussed in our previous discussion. So आप उसको use करते हुए you can find out this probability and find out the answer to this. ठीक है? And similarly, you can find out the probability of no meningitis given stiff neck. ठीक है? ठीक? So this could also be found, provided you have got enough data here. So if you have got enough data here, then you can find out this. And what would be the answer, whether the person is suffering from meningitis or not, whosever probability is higher. So if this probability is higher, then we'll say that the person is suffering from meningitis. And if this probability is higher, then we'll say that the person is not suffering from meningitis. And of course, in order to find out the probability of no meningitis given a stiff neck, for that you'll need to have more data set here, or more data values here in order to find out these values. Okay, I hope this is clear. Is there any confusion on this so far? Okay. Now, let's just introduce some terminology here, and before we actually move on. So, in this particular example, we'll call this probability, which is the probability of finding a disease given a certain evidence. So, what happened first? You observed some evidence, and based upon that evidence, now you are trying to find out whether the disease has occurred or not. Okay, and this probability after the evidence is known to you is what you call as the posterior probability. Okay, so posterior probability, the term posterior is used as it is clear from the name itself. Posterior probability is the probability that is found of a particular event or a particular happening after some evidence is observed. Okay, so this is what you call as the posterior probability. Acha, ye jo probability hai where the evidence given the disease, this is what you call as the likelihood, and these are the priors. Okay, so this is the prior for the disease, and this is the prior for the symptom. Priors are also called the marginalized probabilities. Uh, if in a population you simply find out कि कितने लोगों को meningitis है, that would be the probability of meningitis. और कितने लोगों को stiff neck है, that would be the probability of stiff neck, P. और फिर अगर आप ये find out करें कितने लोग ऐसे थे जिनको stiff neck थी, given they were suffering from meningitis, this is what you call as the likelihood of occurrence of an evidence. And then you simply multiply all these and divide in a way that is given here to find out the posterior probability. ठीक है, और posterior probability को find out करना in order to enumerate or in order to find out whether a certain event will occur or not. Okay, so I mean, from here you can find out the probability of W given dry using the same process that we have discussed earlier. You can try to find out the answer to this small quiz. Okay, I'll come to this example maybe next time, but let me just give you the complete solution, the pipeline solution, and then we'll come to the motivational part of the video if we get some time here. So this is how the probabilistic inferencing process would work. Okay, so you find out the likelihood, as I told you earlier. This is where C is, let's say, if it is a classification problem, I want to classify based upon certain features. X is a set of features that I've got, and C is the class that I want to identify. कि क्या ये फीचर्स की बेस के ऊपर मैं ये आइडेंटिफाई कर सकता हूँ कि ये ऑब्जेक्ट इस क्लास को बिलोंग करता है या नहीं करता. So the first thing that you'll have to do is that you'll have to find out the likelihood. You'll have to find out the probability of features given the class. Okay, and then you also have to find out the predictor prior probability and the class prior probability. Okay, which are given here. Okay, this one and this one. And from using this Bayes rule, you can find out the posterior probability which is given in this particular case. And as I told you earlier, कि अगर आपके पास एक से ज़्यादा features हैं, you have got a vector of features X here, you can always take this independence assumption and you can rewrite this likelihood in this particular form. ठीक है, likelihood formula or likelihood probabilities in this particular form, and that would give you primarily under the independence assumption that x1, x2, xn, if these are the features and you have got more than one features present, then this is how this would actually can be rewritten. So likelihood under the independence assumption can be rewritten in this particular form. और आप इस फॉर्मूला को आप कर सकते हैं. So probability of x, which is the probability of say occurrence of a feature, this is primarily marginalizing factor or a normalizing factors, you can also drop this in order to calculate, even if you divide it with this, uh, the answer here in the posterior probability, or the inference based on the posterior probability will not change. Okay, so this is again the same description which is given here. Likelihood times the probability of class divided by the prior probability of the features, and you can actually do that. So let's just apply it to a scenario and see that how this happens. So in summary, the posterior probability is likelihood times prior of the class divided by the prior of the evidence. Okay. And this is the flow chart. You calculate the prior probabilities for the class, you calculate the prior probabilities for the evidence, you calculate the conditional probability or the likelihoods of evidence given the class, then you calculate the posterior probabilities for the classes, and then your result is, or your inference is the one that has the maximum probability. So let's just apply this to this example that we applied to the decision trees. ठीक है, तो इस केस के अंदर सबसे पहला स्टेप क्या होगा? What would be the first thing that you'll be doing here? From the flow chart, prior probabilities निकालनी, ठीक है, और prior probability of class let's say मैंने निकालनी. So what would be the prior probability of the class? The class table in this particular case, in this table, the last column here is the class. The class is whether you want to play tennis or not. So that's the class. ठीक है, तो इसकी आपने prior probabilities निकालनी. तो prior probability आपके पास कितनी कितनी possible classes हैं? There are two possible classes, whether you play tennis or whether you don't play tennis. ठीक है जी. So for that, my priors for the class would be the probability of playing tennis and the probability of not playing tennis. तो वो क्या values आएंगी जी? Probability of playing tennis and probability of not playing tennis. G. Anyone? Okay, so let me just ask someone. Okay, Hamza have answered. So playing tennis is 9/14. So you simply count how many times you have got a yes here for playing tennis out of the total instances. So that would be 9/14. And the probability for not playing would be, you simply count the number of no's that are present here in this table, and that would be 5/14. Yes. So my priors in this particular case would be of playing tennis, yes, is 9/14, and playing not playing tennis is 5/14. So that's the first thing that we were supposed to do. Okay. The second thing was to calculate the likelihoods or the conditional probabilities. अच्छा, तो conditional probabilities क्या होंगी? Playing tennis given outlook. Playing tennis give so ये तो आपके पास posterior है, लेकिन conditional probabilities यहाँ likelihoods में क्या होगा? The probability of outlook given playing tennis and not playing tennis. ठीक है. Similarly, the probability of temperature, and these would be different values of temperature. It could be hot, mild, and cold, given that a person plays tennis and given that the person does not play tennis. Okay, so that would be the priors or sorry, the likelihoods for that. So let's say what would be the first thing. So let's consider outlook first. Okay, so likelihood of outlook, sunny, overcast, or rain, given a class. So in order to calculate this, you will simply neglect these columns. ठीक है, क्योंकि आपने सिर्फ आउटलुक को देखना. ठीक है, और यहाँ से what you can do is that you can actually generate a subtable of outlook. Okay, and the subtable of this outlook would look something like this. ठीक है, you can easily find out that कि आउटलुक सनी में प्ले कितनी दफ़ा है और नो प्ले कितनी दफ़ा है, ओवरकास्ट में यस कितनी दफ़ा है और नो कितनी दफ़ा है, और रेन में यस कितनी दफ़ा है और नो कितनी दफ़ा है. So this is what you call as the likelihood of outlook given play tennis, or you can call it conditional probabilities. So these are the conditional probabilities. So you calculate the conditional probability, and you repeat the same process for all the other variables that are present, or all the other evidences that you have got. So these four here are the evidences. So in the next step, what will you do is that in the next step, we'll take temperature, outlook, humidity, or wind co. You will neglect that, and you will get a table for that. Similarly, you will get a table for the other variable, and finally you will get the table for humidity. Okay. So these are the tables that you have got, these subtables or the conditional probability distributions that you have got here in this particular case. Okay. And that's what you call as the learning phase. So in the learning phase, from the data, you calculate these things and you keep them with you. Okay. You calculate the priors, you calculate the conditional distributions, and you keep those conditional distributions with you for use in inferencing. Okay, so let's take an example है हमारे पास. These tables have been learned, or these tables have been calculated from your probability distribution table, complete probability distribution table, and now I want to find out answer to this query, and the query is this. Query is that I want to find out whether a person will play tennis or not given this X bar. And what is this X bar? X bar is that outlook is sunny, temperature is cool, humidity is high, and winds are strong. So if these are the conditions, then whether a person will play tennis or not. That's what you have. Okay? That's what you'll have to find out. So can you work out this very quickly? कि आंसर क्या आएगा? Can anyone work out this quickly? So firstly, you'll have to find out these conditional probabilities or the likelihoods. पहले तो आपने, and these are to be done under the independence assumption. We are assuming कि sunny, cool, high, strong, all these can independently exist. They are not dependent upon each other. Okay? That's a tough assumption, लेकिन that's the assumption that we'll be taking into consideration. Right? Okay, so let me just go through this. What would be the first thing that you'll actually be doing? You'll find out the probability of outlook equals sunny given play, and from the table, the value comes out to be 2/9, which is given here. Because our condition is outlook is sunny, so we know the probability, the conditional probability for that, which is 2/9. Similarly, what's the next condition? Temperature is cool. We'll see that the temperature is cool and play yes, the probability is 3/9. Okay. Similarly, you find out the humidity high and play is 3/9. Right? So you calculate all these, and wind strong, again you can find out these probabilities, and you find out all these values that you've got here. Similarly, you find out the values for play equals to no, because we want to find out whether the person will play or not. So you find out these probabilities for play equal to none. So these probabilities are known to you now. Now, when these probabilities are known to you, then you can find out the probability of yes, which given X bar or X prime, and that is the posterior probability. Okay? And that would be the product of all these with the prior of yes. The product of all these with the prior of yes. Okay, so the product of all these with the prior of yes will give you the probability of yes given x prime, and the probability of the product of all these with the prior of no will give you probability of no given x prime, and that comes out to be this. Okay, and now the decision is quite easy. The decision is that which one is the higher? This one is definitely higher. Okay, so the answer in this particular case is that you will not be playing tennis in this particular uh, example. Okay, because the probability of no is higher compared to the probability of yes, and this is what you call as the map rule. Map rule is the maximum posterior probability rule. So maximum posterior probability is your final decision. Okay, I hope this clarifies, and with this, I'll end today's session, and you may focus on the quiz now.